Hey everyone, you're listening to the Simple Electronics podcast, and I'm your host, Dan, from the Simple Electronics YouTube channel. And with me today, I've got a very special guest, Steph Piper. How are you, Steph?
Hey, I'm pretty good. Great to be here.
Well, great. I'm glad you're here. Did I pronounce the last name properly? Because I asked you about the first. I forgot about the second.
Yes, yeah, it's just Steph Piper, as in the Pied Piper.
There we go. Oh, Pied Piper. Did you ever watch Silicon Valley by any chance?
Oh, yeah, I did. Great show.
Yeah, you liked it?
Yeah. Oh, good laugh.
Yeah. So I know a little bit about you because I listened to your podcast appearance over on Billy Rubin's channel. But for those listening at home, could you just give us a little intro? Tell us who you are and what you're about?
Yeah, sure. So I sort of describe myself as a bit of a creative technologist, but in a nutshell, for my day job, I run a makerspace at a university over in Australia in Queensland. But you may have seen some of my projects online, from some of my circuit board design forays into soldering kits that have multiple colors of solder mask and have a bit of an artful design to help get young people into electronics. And more recently, I've also built a big art installation called the Party Button. So you might have seen those projects online anyway.
Here's hoping. If people haven't seen these projects, just go into the show notes, click the links. I'm sure people will be very impressed because I know I was. So really impressive stuff you got going on there.
Yeah, thanks so much.
But
Yeah.
you sound a little bit more modest than these projects would infer, because you said there's sort of creative. You're sort of like a creative technologist, but the creativity is like through the roof. I don't want to make you blush or anything, but honestly, these circuit boards they're a work of art. There's no other way to say it. Can you tell us a little bit about what motivated you to make boards like this?
Oh, thanks so much. I think for me anyway, when I sort of see young girls, especially looking at electronics, you often go to places like in my local area, we have JCar, and the kits that they sell to get you started in electronics are quite sort of, green, your classic solder mask colors, and you're making things that aren't really that exciting to visually look at. And so it's important that we sort of make different types of opportunities for different types of thinkers, I think, to make things that are a bit more exciting to learn from and something that you're excited about taking home. But yeah, I'm so chuffed with your thoughts on the design anyway. To get these to look as good as they do, I ended up going through quite a few numbers of iterations to get these right. Like the cat board especially, that's been like 10 iterations of prototypes. And I feel like I probably could have gone with iteration number 5, but it certainly wouldn't have had the same polish and beauty that it does now.
And polish indeed. Let me just paint a little bit of a word picture for the people listening on the podcast. So the one that draws my attention the most is called the Space Girl Soldering Kit. If you guys go into the Etsy link in the description, you can follow along with my description. It looks like it's an astronaut standing on sort of like my interpretation is a cloud of smoke coming out of a rocket, and the astronaut is in outer space, and there's sort of like, I would say, like a swish of the Milky Way in light purple, and the background is dark purple. The smoke is blue, and then there are details like trails from the rocket, and the cloud surround and the swishes, and all the details look like exposed copper with the gold plating on it. So this is what I'm looking at. It's truly a work of art. How did you even manage to get a board house to print multicolored solder mask, for example?
Yeah, great question. So the design of this anyway, if you weren't familiar with electronics, you might think it looks like an enamel pin, which is what I was going for. But yeah, to get these made up properly, I ended up traveling to China back in August 2019, which is a bit terrifying to think about now in the timeline of things unfolding. But I went over there with my business partner, and I ended up leading a bit of a tour with a few other people who were interested in learning about hardware development. And we went to like this huge Chinese circuit board expo, and we had a translator, and we were walking around pitching what our concept was to all of these different manufacturers. We're saying, look, we want to make something that is, has multiple solder mask colors. And nearly every response in that huge, ridiculously large building of people coming through the translator was, no, we can't do that. That's too hard. Why do you want to do that? Why is aesthetics important? Electronics is not meant to be seen. Uh, all this
Yeah.
kind of response. And we ended up, by fluke, finding one board house that would do it. And we are very grateful that they've been happy to experiment with their manufacturing process with us. But definitely getting these boards made up is more expensive than what you would expect from a standard board house, as you would expect.
So I would need you to correct me if I'm wrong here, because I am just talking out of my butt right now. But from what I understand, when they make circuit boards like this, they have something like everybody's designs on a massive circuit board, and then they just kind of layer on top the solder mask for everyone, and the silk screening for everyone, and etc., and the etch for everyone. And so they do like a massive board at a time. And let's say you order 10 boards. Well, all 10 of your boards would be there, and then 10 of another customer's boards, or 100 of Microsoft's boards, or whatever. And so to make multiple colors, they would have to do multiple passes with, like it almost be like every board is bespoke on that panel. Is that about, does that sound right?
Yeah, so I'm not quite sure the details around the panelization of all of these, but you would have to have no other jobs on the board, I imagine. It would just be all of our boards on the one big sheet, and they'd have to do two passes of the solder mask. Definitely an extra step in the process, and they would usually have to do.
And as far as I know, board houses the ones that market to makers, basically, they sell you basically the empty spots in their runs. And so if you order black solder mask, for example, they're going to put your boards in with customer boards that all have black solder mask. And that's what keeps the price low, which is fine. But I'm looking at your Etsy store. The Space Girl soldering kit is $14 Canadian. I
Mm.
mean, that is not expensive. I don't understand how they did this and kept the price down, because presumably you have to have a small profit at least to cover your operating costs. So it's pretty impressive that it's down this low. Or is there a reason
Mm.
it's lower priced?
We ended up doing a pretty large run with the board house to get the cost down. So we also got them to do all the assembly work for us as well, putting them into the bags and the kits, which is pretty great. But I'm sort of lucky that I also have a day job as well to support these kinds of sort of fun on the side hobbies. So I think if I was directly relying on this as my main form of income, they would definitely be higher. But it's great to keep the prices at an affordable rate to make sure that people can get these in their hands, especially with international shipping. By the time you ship things from Australia to anywhere else, things end up being a little bit more than you expect them to be. But more recently, though, it's pretty exciting that a few of these kits are now available through Pimoroni and Adafruit.
Oh, very nice.
Yeah.
Well, I mean, they do look like a finished shelf-ready product. They do look like something that you would find in a hobbyist store. So that doesn't surprise me at all that Pimoroni and Adafruit want to carry it. So, I mean, it looks fantastic.
Yeah, it's been super exciting to have our stuff with them. It's a huge big tick on the bucket list. And every time I see it on their websites, I just get a little jump of joy, being like, oh gosh, there it is. Oh.
I want to talk about the design process a bit, but first we need to talk
Yeah.
about the cat, because similar. It's a kit, but it also looks like it had its own challenges. So for the people listening at home, again, available on the Etsy link if you want to follow along with my description. But it looks like it's a cat, like in a playful position, but it seems to be, vertical, but slotted and possibly soldered into a horizontal board, which then also has sort of, I think that's a separate piece. I can't really tell. Yeah, separate piece that goes up and does like a semicircle above the cat, and then there's legs that holds the horizontal piece up. Like, basically, if you, as a kid like me, if you had those dinosaur 3D kits that you just slotted together, it looks kind of like that, but much fancier. So
Hmm.
can you talk to us a little bit about the cat, and then we'll go into the design process?
Yeah, so like it sort of looks like a bit of a diorama, and it's essentially a three-dimensional soldering kit where, yeah, as you say, the pieces slot together to make a three-dimensional shape. And to be honest, when you look at like, I don't know if you can click into the listing, but if you look at the flat board, trying to work out how to get all these pieces properly, like in a board that snaps out the pieces, was an absolute nightmare. So, like all of the little tiny mouse bites on there to hold all of these pieces in one board, while also making it easy for a young person to snap out the pieces, was a bit of a challenge. And I went through many iterations of this, and it was a bit of a realization that, oh, I could actually put the larger pieces just on the outside without some kind of an overarching loop that encased the whole shape. So that was sort of really good to click in my mind. Um, but yeah, real adventure. And the board houses absolutely hate when you do weird things with mouse bites. Like they'll come back and
Sure.
they're like, "How could you do this? Are you trying to mess with us with this design?"
Oh, I'm
um,
I'm sure you got a little bit of some engineer scratching his head for
oh
sure.
yeah, if you get the wrong person at JLC on that day, then they look at that board and they're like, "Nah, nah, we're not doing that. You're dreaming." So I had to, for a few of the runs that I did, I had to go through like I was going through like the weird circuit board houses, like the JLC copycat ones.
Okay.
Um, yeah, to try and get these made.
And so, yeah, it's incredibly impressive. It's first of all, it combines the two aspects of the space girl one that I really liked, which is the multicolor. Although this one is a little bit less fancy multicolor, still has black, looks like solder mask and white silk screening possibly.
Yeah,
But
there's no
so it has
multicolor
that,
on this one.
yeah, and it has the aesthetics, but it's also like functional. It has to mechanically fit together. So it has like three aspects of difficult, board design in it. So it's very impressive. Can you tell us a little bit about what's your process like? Like what kind of software you used, and maybe how many iterations this one took as well?
Oh yeah, let me tell you about the software nightmare this thing is to create. So the first thing that I had to do was to obviously make sure it fits three-dimensionally. Like that's the thing that I worked out first. And so I made all of the outlines in Rhino software, like a 3D modeling software, and I was able to superimpose them in 3D to make sure that they did actually click together properly. And then I was able to take those 3D shapes and arrange them into like the board shape essentially. And then I went into Adobe Illustrator and I was able to transfer the artwork onto the outlines, and sort of start to really organize the artwork in terms of board layers as well. Because obviously, like the artwork can only be on, I think, 5 layers. So you've got, oh, it's the words are escaping me this early in the morning. But
That's
yeah,
fine.
you've got
It's
like
8 in the
your
morning for Steph, so cut her some slack, guys.
wake up. Yeah, you've got like your like the bare board essentially, which is like the mask on the layers. You've got the shiny gold, which is a combination of the copper and the mask to reveal it. You can have the gold behind the solder mask, like for a bit of a like a lighter effect, I suppose, on the raw solder mask color. And then you've
Oh,
got
is
your.
that how you got the light purple
That's
on
right.
the? Oh my
Yeah,
God, I didn't even think of that. I thought it was three different colors. Ah, I get you.
yeah, yeah. You got it. And then of course your silk screen, which is the white on this board. And so yeah, you have to like split up each one of those different colors into a different image file, essentially, where like it's highlighted in black generally. And then that goes into Inkscape, where it runs through the classic SVG to Shenzhen plugin, which converts it to KiCad software, which is the one that I use. Um, to be honest, KiCad is extremely fiddly for this kind of artwork, and I sort of really want to start branching out into other software to see what it's like to do art PCBs. But yeah, you import all of those separate layers into KiCad, and then you realize that uh, all the artwork now interferes with the actual circuit itself, and then you start the process again.
Oh no.
And then you realize you should have done the schematic first.
Yeah, KiCad being finicky for art PCBs is like the understatement of the year, and it's only January. So,
Oh yeah,
have
like so much clicking and dragging the little tiny point nodes to make them fit. Yeah, gosh.
yeah, and the alignment tools. I mean, sorry, the non-existent alignment tools, because it's basically to a grid instead of like you can't distribute, you can't like center things to themselves and stuff like that.
Oh
Have you
yeah.
tried the new revision of KiCad though, KiCad 6?
Ooh. I'll have to have a look.
Yeah,
Can't
they
tell they
have
updated it.
fixed a few of the problems. They just released it either the end of December or at the beginning of January. It's the first major revision in a while,
Mm,
so it is nicer. But I'm not sure if if there's any more art tools added to it. I don't think that was their focus, but maybe in fixing other things, they made some of those things easier.
what I'd really like to see is a scale tool,
Oh
because
my God,
it's
please!
yeah, it's so often that I'm like, oh yeah, I'll just add a logo to this board. Then the logo's like, it's too big or too small, whatever it is. And then you have
Yep.
to, you have to start from the art process again, where you scale it down in Inkscape, and then you import it in, rather than just have a scale tool, which would make things so much easier.
Yeah, and the mentality I think is just like the board manufacturers, right? Like they're just thinking PCBs are more like behind the scenes type things instead of front and center. So that's not their major concern. But
Mm,
the funny part is I'm fairly certain that the Gerber files for those listening are what you export your board into that board house will use to build your boards. I feel like they're I think they might be vector based as well, Gerber files, because I don't see, because the resolution will depend on the board house, which kind of means it's some sort of coordinate type system instead of like a compressed sort of JPEG type thing.
mm. Yeah, I think that would make sense to me. I don't know whether that's true or not, but it seems like it would be from my
So
experience.
it would be interesting if you could um, maybe import the Gerbers directly into Inkscape and then modify them like that. I think that would be pretty neat.
Mm. Oh yeah, that would be pretty cool. Yeah, I
Yeah.
think any way that you could skinny down that software process, because that's like what we got: Rhino, Illustrator, Inkscape, KiCad. Yeah, that's like 4 softwares. So
Oh yeah.
yeah.
And that's not counting what the board house uses as well.
Oh yeah. Yeah.
So yeah, it's a big pipeline.
Mm.
Maybe maybe that's your namesake, Piper. You just have to you have to put all your stuff through a giant pipeline.
You must learn every fringe software
Oh my God.
to do this project. Oh yeah, that's what it feels like.
Um, I think you also didn't mention that you had some sort of biomedical background in your intro. I guess because I feel like you're, I don't know if that's a derogatory to say, but a Renaissance woman. Like you have sort of you seem to be a jack of all trades, actually a master
Hmm.
of all trades, if I can comment that. Um, so can you explain a little bit about your background? I also want to get to the 3D printed cast that I see so prominently in a lot of your display pictures.
Oh yeah, yeah, cool. That's my science Thanos picture. Uh,
Oh,
but
brilliant. I didn't even think of that.
Oh, that's great. Yeah, so I left school and was pretty keen on science, and so I did a Bachelor of Biomedicine. Went on to do a honours year in vaccine development, but at that time, I ended up getting super interested in 3D printing. And this was sort of back around 2011, where like RepRap was still in full steam. Like it was only just sort of coming into prominence that you could go and buy a RepRap kit online, put together the parts yourself, and make your own little 3D printer. And I ended up having a go at doing that in my little room on college. And yeah, I thought, like looking at the medical 3D printing space, I thought, yes, that is where I want to go. That's what I want to do. And so, yeah, I ended up being able to actually approach a professor with some parts that I'd made on a Prusa Mendel that I'd built, and to try and get on a PhD program looking at 3D printing body parts. And yeah, I showed it to him, and he's like, "Yep, you're on the team." So I ended up working for a year in the 3D printing of body parts space, specifically in soft tissue engineering. Um, and yeah, it's sort of pretty funny to look back on now, but I was working on a project 3D printing breast scaffolds. Yeah, it was wild, but essentially like the concept of the project was that like we would um, find an alternative to silicone implants for breast cancer patients. So normally, if you have breast cancer, you may need to go in for a mastectomy or a lumpectomy to remove that cancer, and you end up being flat chested essentially, where you know you've lost the shape essentially, like the whole the tissue, and that can sort of present patients with you know a bit of a loss of self identity and a sense of self and all other kinds of you know mental health type issues. And so some women choose to go and get implants put in to retain that natural look. And of course, implants have all of these other huge rainbow of problems. And they're sort of a little bit terrifying when you start to dig into them. Like, you're meant to have them removed every 10 years. Um, but anyway, we were developing a biodegradable scaffold. And the idea was that you could implant it in as an alternative to this process where you could ideally sort of, it would like biodegrade over, you know, 2 years or so, and it would be slowly replaced by your body's own fat tissue, essentially. And so you'd be left with something that was a more lifetime solution. Um, anyway, the project was pretty wild, and I sort of ended up leaving after a year. But it was a pretty good intro to some of the great medical 3D printing, like the different processes that are used, the different materials, and I really got to start cutting my teeth on a whole variety of weird and wonderful 3D printers.
Could you? So all this is super interesting. I find myself when I'm talking on these podcasts, I want to show my interest, but then because of the delay, sometimes that makes my guest stop speaking. I didn't want to stop you, so I wasn't ignoring you. It was very interesting. Let's see, where do I start? What sort of challenges were you actually working on when we're talking about like a soft tissue scaffold like that? I mean, I assume you can't just use any material, right? It has to be body safe, and it has to be flexible, and it has to be, yeah. What kind of
Oh
challenges
yeah.
were you dealing with there?
Oh yeah, like and especially and throwing in the extra thing of it needing to be 3D printable as well significantly reduces the things that you can use, especially at that early stage in time as well. So I think things have probably come a little way since I was on that project. But what we were using is PCL, plastic polycaprolactone, which is now actually marketed as a kid friendly like lower melting temperature, safe filament for use in stuff like 3D pens and like kids specific 3D printers, which is
Interesting.
pretty interesting. Yeah, it's like the same stuff as what Plastomake is made out of. the stuff that you buy a tub full of pellets and you can mold it with your hands in hot water and you can shape it into new things.
Oh
Um,
yeah, I've seen that
and
stuff. That stuff's really interesting.
yeah, and so that has like like biodegradability. And so the main problem with using that though was actually trying to sterilize it for the animal trials because you can't just chuck it in the autoclave. You know,
Oh yeah,
it's got
it'll
a
melt.
melting temperature of
Yeah,
like, oh no.
yeah.
Yeah, because it melts at 110 degrees and the autoclave goes beyond 200 degrees, I think. Um, so yeah, it wasn't going to happen. So we had to get them ultrasonically sterilized by another university down south, and so that was a huge, like, time-consuming process to actually package them up properly and get them sent away for that. Um, but yeah, like there seems to be quite a few other materials out there, and some pretty promising hydrogel research, where you can like you essentially make biology jelly, I suppose, and you can grow cells and do 3D printing inside a jelly matrix, which holds things together a bit easier.
Ah, so overhangs are
Yeah.
less of a problem too.
Mm. Oh yeah. Yeah. So yeah, definitely a lot of potential in that space. Um, yeah.
Are there any like current stuff you see on the market in the 3D printing world that you think, wow, like that would have been nice to have when I was working in this industry?
Oh yeah. Like just just purely working in the old school slicer software, the slicer with the three. I don't know
Okay,
if you
yep.
ever used that one, but yeah, it's very old school. And you put in a file that's too big, it crashes. You
Oh
do
no.
anything weird, it crashes. So I feel like yeah, we definitely be able to do many more powerful things with the software that we have now. Like just made leaps and bounds. And yeah, I found myself too often in that lab late at night or early in the morning with a 3D printer that wasn't working. And oh yeah, like we just yeah, the actual design of the 3D printers, like we forget we've only really had 3D printers like in their desktop form properly for like, only 10 to 12 years. So
Oh
yeah,
yeah,
there was
and only
yeah.
accessible for the last like 7 years or so.
Oh yeah. Yeah,
They
yeah.
were
So
quite expensive even in kit form, if I remember correctly.
mm, yeah, I think my Prusa Mendel that I ordered in from India or somewhere wild, was $500. Yeah, and now
Yikes.
you can get like, a beautiful Ender 3 for yeah, less
I
than that.
think, yeah, I think in the States you can get two Ender threes and about 6 months worth of filament for $500.
Yeah, yeah, yeah. That would be Australian dollars as well. So, um, yeah, I suppose maybe 400 or 450
Yeah, I mean,
US.
yeah, the prices have come down, and I think the quality of components have come down too, with like the linear rails or even those Delrin rollers and stuff. I think it's just impressive how
Mm.
inexpensive the raw components have become. Mind you, printers have also become a race to the bottom, but it is what it is, I guess.
Oh yeah, too real. Another type of 3D printer that we had in the lab that was pretty exciting at the time as well, that I'd be interested to check back in on, was the Electro spinning machine. So it's a bit of
Ooh,
a
what's
like
that?
a ooh, it's like a research 3D printer that essentially can 3D print the thickness of a spider web, and it looks like it's spinning little tiny spider webs. And how it works is it has a very high voltage that pulls these little tiny strings of plastic, and it sort of needs to, like, I don't know how I can't remember how it actually worked, but like it was able to maintain like a static electrical field in such a way that the thread wouldn't just whip everywhere and get lost. It would actually be laid down in a very precise process, and so you'd be able to make these beautiful spiderweb looking scaffolds in tubes and sheets, yeah, using the electro spinning machine.
That is super fancy.
Mm,
Here I was
yeah.
thinking the laser sintering was going to be the future of 3D printing. That sounds a lot more futuristic to me.
Mm. Yeah, it'd be interesting to see where it's at now, since I last looked at those machines.
Yeah, I'm like I said, I'm excited for laser sintering because I'm a more of a hard material kind of person since I'm automotive mechanic by trade, and I teach the automotive trade. So to me, the possibilities of like basically growing apart, uh, starting from powdered metal that is just as strong as a metal ingot, is super impressive to me. The day that those things become available for home use is the day, you'll never see me again. I'll be in fusion all day.
Oh yeah, it's a shame they're so expensive, but it looks like Formlabs now is releasing. Oh, it's some kind of metal 3D printer, but it's I'll have to find out whether it's actually laser sintering. There seems to be so many different types of metal 3D printing now. Like, have you heard of cold fusion spray printing?
No, I have not.
I only just heard about this the other day myself, but apparently it's when instead of like laser sintering, you run like the little tiny metal particles through essentially like the power of a jet engine. Like it's running around really, really fast and it gets just spat out at a stupid speed onto the platform and it just gets fused in because it's moving that fast as like a cold fusion process.
Huh. I
Wild.
feel like Joel, the 3D printing nerd, may have featured one in his recent. He went to a convention not too long ago. There was something about like that. It was just the stuff was deposited, like it was just as fast as you can fire it out, basically. So maybe that's what it was. And I guess you did a good job explaining that one. I should probably explain laser sintering to the audience too. So laser sintering is you have like a tub of powdered metal, and it's whatever metal you want. There's some that work really well and some that work less well. But you fire a laser to solidify a layer, and then there's like a squeegee that comes over and puts a new layer of powder on top of it, and then it fires a laser, and it all kind of melts together. Really impressive stuff.
Mm, yeah. One day we'll have one of those.
Yeah.
Yeah.
And
Just give me a
so
bit of time.
using what kind of technology did you use for the medical Thanos glove?
um, yeah, so after I left that PhD program, I ended up branching out and doing quite a few medical 3D printing projects of my own without sort of the backing of the research group. And this one was just made on my standard at-home FDM 3D printer. At the time, I had a couple of Lulzbot TAS 5s. Yeah, so the story behind that project is essentially, so on my profile picture online, you can see me wearing like essentially a 3D printed cast for broken bones. And it's got lots of little holes in it. And essentially, like this project started when my local hospital approached me and said, hey, can you do up a prototype for this particular concept? And I said, of course I can. Is this a challenge? Uh, anyway, I ended up getting my little home jobby 3D scanner. It's just a PrimeSense Carmine, little handheld one, and I 3D scanned my arm, and I imported that into Rhino software once again, using the Grasshopper plugin, which is used for mathematically mapping and using algorithms to make 3D models, often quite popular with architecture types. Yeah, and I was able to map the Voronoi style pattern onto like an offset of my 3D scan of my arm and make this prototype, which essentially, like, whenever I go and visit schools or do 3D printing talks out in public, I usually bring it along and show that this one is designed to fit me exactly as a demo. And since doing the project anyway, I ended up making customized versions of these for some of the hospital executive staff so they could wear them to a conference and show them off. But it still remained very much a concept anyway. And since making it, I've made the process open source. It's now up on Instructables, and anyone can go ahead and like go and make their own custom ones if they would like. But obviously, it is still very much a prototype, and I never did any trials or anything like that. I often get emails from people that are like, "Hi, my auntie's going into ankle surgery soon. Can you make her a cast?" And I'm like, "No, it's not. It's not.
Not a chance. Come on.
It's not medically certified at all. It's a bit of a honestly, it's a bit of a concept prop. And I think realistically looking at it, it's probably more suited not for broken bones, but probably for more long term, like wrist injuries and that kind of thing, where you need some kind of a support, and having that level of breathability with all these little holes in it, is worth your time to make it. And so the idea is that you can heal with having a bit more breathability and aeration than a standard plaster cast or something that would cover your whole skin. So you could go for a shower, go for a swim, get a cool tan, obviously. All the important things during the healing process.
Yeah, absolutely. The swim and shower, I think, is the big deal, because when I severed a tendon in my left hand at work, and showering was just a pain in the butt. I had to cover my
Oh
cast
gosh.
for it wasn't that long, because it wasn't a broken bone. It was only like a couple of months, maybe a month or two. But still, I mean, I would have loved a plastic cast that didn't feel like I had a glove on all the time, a rigid glove. It felt, I would love to have felt some air on it. And I'm sure people who have had casts would appreciate the fact that you can scratch yourself a lot easier with a Holy cast like that.
Oh yeah, especially kids as well. You go into the doctor and the doctor's cutting your cast off, and he's like, "How did you fit 5 pens in here?"
Yep, kids.
Yeah,
Definitely not
yeah.
me.
Itch.
100% kids.
Oh yeah, itchy times. I think some of the most promising startups that I've seen in that space, though, the best one that I've seen is called Xkelet, spelled Xkelet. Yeah, if you're interested in those types of casts, this is the one to keep an eye on, I think. Yeah, it looks beautiful.
Interesting. So they would use similar technology. They would 3D scan and then sort of use software to create the pattern, and then probably some sort of SLA printing, I'm assuming.
Yeah, that's what it looks like from their website now that I'm looking at it again. But yeah, at the moment, especially when you start looking at hospital process, making a cast like that for everyone that has a broken arm is not feasible. Plaster casts are still so cheap and fast for them to put on, and you're not sitting around for 4 hours in the CAD software trying to work out what's wrong with Grasshopper again, to actually get these made. So it looks like they're not only doing the casts, but they're also building the software process for you to essentially stick your arm in a 3D scanner, and they've got a software that can easily just make that cast for you.
Oh
Yeah.
yeah. And I think for the home gamer, it'll be a game changer. Like stuff like splints to keep your finger straight, for example. That's
Mm,
something that you or I could probably design. Well, you probably do it a lot faster than me, but you or I could design it at home and print it at home, and you would you'd probably be able to have it on your finger 2 hours after you first open your software, because it's small. The geometry is a lot more simple, and stuff like that. But yeah, I mean, I'm sure your arm cast took probably about 6 hours or more to print. Am I right on that one?
yeah. Yeah, that is
Takes a little
correct.
bit.
Yeah.
What material did you print it out of? Just straight PLA, or did you go something exotic?
Nah, I just went straight PLA, but I do have a roll of antibacterial filament that is threatening to be used for a project at some point. I don't
Oh,
quite know what,
fancy.
though. Yeah.
What are you before we move off 3D printing, what are you 3D printing these days?
Oh, just all kinds of stuff. Yeah, I sort of I haven't really been working on any big 3D printing projects recently. Just lots of little bits and pieces here and there. In 2020, just like everyone else, I was part of that 3D printing face shields movement, um, and sort of championed that in my local area. But yeah, otherwise, recently I ended up upgrading to an Ultimaker S3, which is a bit expensive. But it's so nice to come home after a day at work working with 3D printers and actually have a machine that will actually do its job without failing or needing me to look at it and give it maintenance, like the pork realities at work.
Yeah.
Yeah.
Yeah, a public reality would probably be worse than a private reality, but yeah. If
Oh
for
yeah.
those of you listening at home, there are machines that are set it and forget it. But that's not the $300 machines you'll find on Amazon. It just isn't. It can't be.
Yeah.
Although, some people get very lucky. Like for me, I have probably the world's cheapest printer back in 2016, I think, when I bought it. And it's given me very little grief. Like every once in a while, it'll forget that it has a bed sensor, and it'll just crash into the bed, and then I'll have to reset it. And then you know what? You power cycle it, and then it's like, oh yeah, bed sensor, and then it starts working again. So it is what it is. I don't ask it any questions. It just does its thing.
A 3D printing miracle.
Basically, I mean, that's kind of what it is. The firmware on this thing is such garbage. Like it doesn't have any feature that like a bottom of the barrel printer today would have. It doesn't have like filament loading or filament unloading.
Classic.
It doesn't have like filament retract after print and stuff like that. You can do it in the G code, but like it has nothing. I'm not even kidding. It does nothing.
Yeah.
So yeah, that's my Tronxy X3A. I wouldn't recommend it to anybody.
Oh yeah. Well, if it does the job, that's all that matters.
It does the job. And in fact, I think, yeah, looking around, it's my most reliable printer. I've got 3 printers here, and it's my most reliable one, probably because I've actually put the most attention into it. So it's not too bad once you start fixing the bugs.
Yeah.
So then, your party button, which I found really impressive for a few reasons. One, it's a really neat project, but 2, it's not really just a project, isn't it? It's an art installation. So how did you end up with a public art installation?
Yeah. Not really somewhere I ended up expecting to go, to be honest. But essentially, to paint a picture, it is, in its current form, 2 meters tall, and it's made out of polished, welded stainless steel. It has like a literal traffic light button affixed to it, and you go up and you press the button, and it plays one of 20 randomized party tracks, and there's a couple of crosswalk characters on LED matrices up the very top, and they do a little dance when you press the button. So it's essentially like a silly replica crosswalk. And so that project began a couple of years ago now, when someone brought in some real traffic light walking man lights. And yeah, they said, Steph, do you want to do anything with these? Holding them up. And I was like, of course I do. I need to do something cool with that because, yeah, you don't get these very often,
Sure. And in like industrial design, rugged as all hell. Like it.
Yeah.
I would love to get my hands on those. Oh, and just by the way, for those of you in the U.S., Liberia, and Myanmar, 2 meters is just over 6 feet. Just so we're clear.
Excellent. And so I got this thing, and also I'm pretty sure that my buddy did not go and get it with a special kind of screwdriver. I think they were getting rotated out, and because they were a bit older. But anyway, I got this thing, and I eagerly started to rip out all the old green LEDs, and I replaced them with my rainbow color cycling LEDs. You got to do it. And ended up rigging it up with a SparkFun wave trigger, mounted on a PVC pipe with a swivel chair base, looking real janky, and set up an early version of the party button just as a bit of a silly time in the makerspace, where people who didn't really have an idea of what Arduino was or electronics or what was possible could come up and press the button and experience Darude Sandstorm or whatever else I'd loaded on there at the time. I just put on a bunch of meme tracks, I think. So it was pretty funny, and a lot of people loved it despite its jankiness at the time. And I ended up seeing someone sent me the link to a grant application for the Curiosity Arts Exhibition, which is in Brisbane, and I ended up putting in an application, and I said, look, this is my prototype. You can see it works. You can see I can do it. How about you give us 15 grand, and I will go and make a beautiful metal chassis for it, and I will turn it into something that can be suitable for public display in an outdoor capacity or whatever. And
Fairly cheap for a one-off art piece, I must say.
yeah, I thought so.
15 grand is not, if someone's looking for a bespoke piece of electronic art, 15 grand won't cut it.
Yeah,
just
yeah.
so people know.
Yeah, I'll have to up my prices next time, I think.
I think so.
Anyway, they called me up, and obviously, as you can tell, it was a good deal. And so they said, "Hey, how about you build two?" And I was
Oh
like,
God.
"What?" I was like, "What?" Okay. Anyway, cue 6 months of madly figuring out what the hell I am doing with this project. Like, I'd never designed anything for metalworking before, and I was very lucky to find a metalworker who was very forgiving with my design and was able to make it work with the process that he had. But yeah, I fully designed it in Fusion 360, and yeah, like, oh my gosh, I think the main crazy emergency that we had with this project was a week before it was meant to go on display. So
Oh God. Here
yeah.
goes. My anxiety's going up already.
Oh Lord. Yeah, so like part of the project is you can't just bolt it down. Obviously it's really tall and it's in danger of potentially toppling over, especially in Brisbane where you've got all these bloody electric scooters hooting around everywhere. And yeah, if someone clocks into it at 100 k's an hour, you sort of, you don't want it to topple over and crush a child or something.
Oh yeah, I was thinking
Yeah.
about damaging your art, but yeah, sure, crushing a child, that's important too.
Yeah. Anyway, so we had to figure out a way to weight it down without bolting it down. And so to do that properly, you've got to, like, it's part of the actual art process. You've got to hire an engineering firm to certify that it is fine to be displayed in a public place. It's part of like the insurance as well. Like it's a special certificate you can get. And so the engineering firm analysed my design, and a week before it was meant to go on display, they came back and they said, "Look, Steph, you're going to need to put an extra 350 kilos in the base." And I was like, "What?
Where are you
It
gonna get
already
350
weighs."
kilos?
Yes. I was like, "What?" And I was like doing research, I was like, okay, this thing already weighs 100 kilos, like by itself. And I'm like looking at gym weights online. I'm like, okay, so if we stack flat plate gym weights in the base, they'd be too large. They wouldn't even fit in there for that amount of weight. And I was like, gosh, what am I going to do? Am I going to be breaking into the local defense base and stealing some spent uranium?
Yeah,
Like
probably
the weights
because
they use in helicopters?
yeah,
Like,
because for those of you listening from the U.S., Liberia, and Myanmar, that's 770 pounds.
thank you for the speedy conversions there. I love it. And oh gosh, yeah. So I was like, okay, I'm gonna break into the science department. I'm gonna steal some tungsten cubes. Like what else am I gonna do here? And so I contacted the engineers back, and I was like, look, why have you done this to me? What, what do I need to be doing here to fix this problem? And they said, oh yeah. So what you need to do is you need to make some flat plate stacked steel pieces like that all stack up in like a ziggurat shape or like a pyramid type thing inside the base. And I was like, oh, okay, let me just get that done a week before it's meant to be on display. And yeah, anyway, I contacted the metalworker, and this guy is, yeah, just constantly an absolute champion. And he's like, yeah, I can make those up this weekend. And I was like, oh
Wow.
gosh, thank you so much. Anyway, yeah, these weights, honestly, like I can sort of pick them up and stack them up myself, but it makes it a colossal pain in the ass to set up in public. So yeah, I've had to sort of hire a storage unit to put it all in now. And it can stand up by itself and not be pushed over easily when it's in an indoor space. But yeah, if it gets hired out again for more outdoor events, yeah, I'll definitely have to hire some burly people, I think, to help me move these weights around.
Yeah, I'm looking at it now. It's a lot chunkier than I had first perceived it as. I'm looking at the pyramid shaped base and how big the first section of it is. How high do the weights go in there? Is it like all the way up to the button or not that high?
Not that high. So it sort of goes up to the first, like the first, like it's the triangle base bit, I suppose.
Okay.
That's where it
Okay.
goes up to. Um,
Man,
yeah,
that is impressive. So you got 350 kilos worth of steel in there?
yeah,
Wow.
yeah.
That's impressive. And because I guess when you said that, the first thing I thought of would be lead. But lead is so expensive. And then if
I was looking at
you
lead.
yeah, and if you put like if you let's say you could pour lead is a for those listening is a low temperature melt point metal. So you could like melt it and pour it into the base, but then how are you going to move the damn thing after? There's no way. Like not a shot.
Gonna have to start getting some protein shakes.
Yeah,
Uh,
no kidding.
yeah, and
So, but
like at the time when I was designing it, like the organizers were like, okay, don't use water in the base because it could leak everywhere and you have rust and such. But when I actually arrived at the actual art show and was looking around at all of the other things that people had made, yeah, there was other things that had really nice like water tub bases, and I was like, oh gosh, why didn't I just do this?
yeah, really.
Yeah.
How does it feel though to have something of yours? Well, I guess it's not the first time, but something of yours out in public like that. How do you react as a maker to see something you built out there and people enjoying it?
Oh yeah, it's definitely still a bit of a level of disbelief, to be honest. Like, yeah, yeah, especially seeing people interact with it as well is pretty fantastic. And like, yeah, I did quite a few sessions where I ended up like sitting out next to it and yeah, seeing what people were doing with it and seeing how they interacted with it. And yeah, I got recognized by one person who was actually looking at my webpage from the QR code at the time.
Nice.
Um, but yeah, otherwise, yeah, people just wouldn't know, which is wild. And yeah, it's a very cool feeling. And honestly, the whole project was like a bit of a wild challenge, and I felt very much over my head, trying to make some of the electronics a bit better than it was in the original crappy prototype. But yeah, definitely worth the effort to see the result.
So, to those of you listening at home, I'm not trying to detract anything from Steph. I mean, I think it's genius. But what she just said there, where she felt over her head, it seems like a lot of the people that I talk to about their projects, are in the exact same mind space. So, if you're thinking that everybody you see online is an expert and they got everything done in their first try, it's probably not true. There are some people like that, but as you saw, like Steph is an iterative person. It's okay to be an iterative person too. Did I nail that, or
Yeah,
did I just insult you? I hope not.
that is so true. And yeah, I think people often don't really see a lot of the failed projects behind the curtain or the iterations that are like, oh gosh, why didn't this work? Yeah, and I find myself in that position quite often. Like that China trip that I told you about at the start.
Yeah.
That was actually to launch a Kickstarter campaign that ended up failing. Which, looking back, I was sort of glad it did. But yeah, yeah, there's a lot of failures that build you up to where you are now. I feel like.
Oh, for sure. Yeah, failure is such a weird. It's such a charged word, and there's no reason for it to be. I think as makers, we need to look at failure as an iteration, like maybe not a failure, but a turn you took on the way towards the answer. I
Mm.
guess that would be the best way to the best way I can articulate it, at least.
Oh yeah, and you've got to be like you can't take the failures to heart. Like you can't sort of beat yourself up about it or anything like that because it's all about just having a play and having fun with the process. Um, yeah, and learning along the way.
Yeah, when I get a new apprentice and they're working with me at the shop or whatever, and they come get me, they're like, "Uh oh, I dropped a bolt and I can't find where it went," because cars are fairly complex. There's a lot of little nooks and crannies. What I tell them is, "Look, I've dropped more bolts than you've seen, so we'll figure it out. Like we'll deal with it. It's a step on the way."
Don't check under the far cabinet.
Yeah, those are called Wii parts. They go right hand and then left shoulder, so right over.
See that carpet over there? We don't use it anymore because it's filled with bolts.
There we go.
That's where they all went.
Okay, so unfortunately, what this happens when I speak to interesting people. So, your number, what, 37, 36 of those, because if you don't count my solo episodes, time has just flown by. And
Mm,
I have a question that I ask every single one of my guests. Do you mind if I shoot it to you?
yeah, go for it.
All right. So the question goes, you get a government grant, so think unlimited money, to start the business of your dreams. But it doesn't have to be profitable because you'll just get topped up, but it must provide a service or a product. What kind of business would you start?
Oh, yeah, so easy. Honestly, I've been dreaming about vending machines for a little while. Um, yeah, like the idea of like making like completely bespoke, custom fantasy sci-fi vending machines. That just dispense weird stuff or like fun stuff. Like at work, to be honest, I'm actually pitching the idea of doing an art vending machine where we can start to think about, getting some of our art students making products that could go in, a vending machine. But yeah, I'd love to like completely design something from scratch that like honestly it'd be so much ridiculous metalworking and yeah, like practically speaking, after having done the party button, working with things that are too heavy for me to lift is probably not the best idea. But yeah, with infinite money and infinite time, I would be releasing all of the sci-fi vending machines. Yeah.
So can you tell me, is it the machine itself that would be a little bit weird, the stuff it dispenses, or both?
Yes. Yeah. So like,
Yes.
yeah, like I don't have any concrete like ideas, but yeah, like like some kind of a wild and wonderful little character or personality, or like something that's just like a big huge dome where you can see everything in the top, or like weird spins on claw grabbers, or like I don't know, stuff that you sort
Yeah.
of would not expect to see because you've thought about designing it creatively rather than practically. I suppose.
Yeah,
Yeah.
that sounds awesome.
Mm.
That is really cool. When you first said vending machines, I was thinking like electronic vending machines. So like you need a push button at like midnight. Well, you go downtown and use a little vending machine. But I like
That'd
this idea better.
actually be a pretty cool concept, like having an escape room style, thing where, or like some kind of a puzzle solving scenario where you get clues from a vending machine.
Oh yeah,
Yeah.
that would be interesting.
Oh yeah. Yeah, that'd be pretty cool. But yeah,
That's pretty
chain
sweet.
vendors are so expensive, but I used to be pretty active at Brisbane Hackerspace, and we had all kinds of weird and wonderful vending machines there. We had one that was only exotic drinks, which means probably the drinks that you were used to at home, but exotic for us in Australia. And we had it set up so that you could like, it had like the villain from Ghostbusters 2, like the painting.
Okay,
Um,
yeah.
on the front, and every time you dispense something, it would shout an angry quote. I think Vigo is the name. Yeah, it would shout an angry Vigo quote, but because it was like based on loud sounds, like it would say something when like a loud sound was heard. It sort of picked up like random noises in the middle of the night, and it would just shout angry quotes to whichever poor soul was there at 3 a.m. and it became a bit too spooky.
Yeah, I wouldn't want that in my house. I wouldn't sleep.
Oh God. Yeah, so good.
Well, we just need to close up a little bit, but I do want to hit on something that I find important, but I feel like it's not really my place to say. But I see that a lot of your soldering kits are marketed to or about girls. Can you maybe tell us if someone has like a daughter, a niece, a female friend, what can they do to encourage a curiosity in electronics and making in general?
Mm. Yeah, so that's a great question. I feel like uh, having a bit of a STEAM approach to learning can really help with a motivational factor. So when we're talking about STEAM or STEM, STEM is like it's like an educational sort of acronym where you're talking about science, technology, engineering, mathematics, and having STEAM or the A in that is adding in the arts. And so turning it into something that turning in like some kind of an electronics project into like something that has a fun outcome, something that they're excited about building, is key to getting a bit of an interest in it. Because like you can sit down with your old Arduino kit, and you can sit down and blink an LED and move a motor, but once you start thinking about maybe like one of my activities that I uploaded recently was how to make your own companion bot. If you took a spin on that and you made, instead of blinking an LED and moving a motor just by itself and then packing the kit away, what if you did that inside a little robot character that your child has designed themselves? Like having that extra level of creative thinking can motivate the technical stuff if it's tougher to get them interested in that kind of way.
Yeah, very
Yeah.
valid. And don't forget, for those listening, uh, kids are the creative types. We are the ones as adults that temper their imagination, right? We tell them, no, that couldn't happen. That doesn't work. So if you're worried about your kid or someone you know's kid being creative, that's not the block. Usually the block is exposure and maybe like ideas and stuff like that. But the creativity, they've got this on lock.
Oh yeah. The creativity is the catalyst for them in doing fun things. I feel like if you can turn it into an aspect of play, yeah, that makes it really powerful. Obviously, creativity is not useful for every project that you do, but yeah, it definitely is a burning catalyst for a lot of people to get them excited and inspired and motivated to do the harder things.
Oh, that's pretty awesome. So can you tell our audience then, where would they go to connect with you? Where do they go to read up about you? Where would they go? Where do you want to send people?
Yeah, so if you're on Twitter, you can find me on Twitter at sjpiper145. That's my handle. Otherwise, I also have a blogging website. You can find that at piper3dp.com. And if you want to check out any of the stuff that I make and sell, you can check out my Etsy store, which I sell internationally too. And there should be some links down below.
Yep. And in the background, if you're listening on YouTube, and I really do recommend you guys go check out Steph's stuff. At least go take a look, because even looking at the PCBs should at least tell you the type of person Steph is, and what she's capable of. And it's quite impressive. And maybe pick up, if soldering's not your thing, pick up a poster, gift it as a gift. They're on the Etsy store as well. Everything looks really good. And Steph, thanks so much for joining me today.
Hey, thanks so much for having me. What a pleasure.
Awesome. And yeah, you guys better go check out her stuff, or else. And I'm wagging my finger, but you can't see it. Thanks for joining me. And everyone, thanks for listening. We'll catch you in the next one.
Thanks.